If you take a brand new enterprise switch right out of the box, rack it, and plug it in, it is completely defenseless. Anyone with a standard serial cable and a terminal emulator can connect directly to the back, hit enter, and take total control of the node. There is no username, no password, and no cryptographic challenge required. Manufacturers ship hardware in this blank state for a reason. If they forced a default factory password, that credential would eventually be published online, creating a universal backdoor for every unit shipped. This default state provides the flexibility to integrate the switch into your unique infrastructure. However, leaving the hardware unprotected once it is mounted in a production rack is operational negligence. Today, we are going to step into the role of the network engineer to systematically rebuild this device as a hardened, persistent network fortress. We begin in user exec mode. Think of this as a waiting room. It is a restricted state where you can run limited diagnostics but cannot alter the operating state of the device. To move past the barrier, we issue the enable command. This transitions the session into privileged exec mode, granting the administrative authority required to rewrite the devicer's logic. From there, we enter global configuration mode to assign a unique hostname. In a complex topology, relying on default names is a quick way to accidentally reboot the wrong core switch during a maintenance window. Once the identity is established, we secure the physical serial connection. We enter the line console 0 sub-configuration mode and define a password for the port. Here is the trap. Defining a password variable does not actually trigger the authentication process. In this state, the deadbolt is installed, but the door is still swinging wide open. To engage the lock, you must execute the login command. This flag tells the port to intercept every new connection and demand the credential before granting access. Locking the physical console port is only the perimeter defense. The internal operating system still requires a digital vault to protect administrative privileges. The legacy method for protecting administrative access uses the enable password command. While it creates a barrier for the session, it introduces a systemic vulnerability in how the device stores its own configuration. When you audit the running configuration, as shown here, the administrative credentials appear in completely readable plain text. This is a massive liability. Anyone looking over your shoulder can read your credentials. Furthermore, if a centralized backup server is compromised, an attacker gains full control over your entire enterprise infrastructure. To resolve this, we use the enable secret command. This modern protocol overrides the legacy password and passes the input through a cryptographic hashing algorithm. Now the configuration file displays only a complex string of alphanumeric characters. Even if the backup server is stolen, the attacker cannot read the password without running a computationally expensive brute force attack. Finally, we use the global command service password-encryption. This instructs the system to sweep the entire configuration and automatically scramble any remaining plain text credentials. These steps bridge the gap between legacy automated scripts and the strict requirements of modern enterprise security. Next, we establish a message of the day, or MOTD banner. Because this command accepts open-ended text, the parsing engine requires a unique delimiter, like a hashtag, to mark exactly where the message begins and ends. A text banner will not stop a botnet, that it is a foundational legal control. To prosecute cybercrime, you must prove a threat actor knowingly exceeded authorized access. The banner removes the defense of implicit permission. At this point, the security model is complete, but incredibly fragile. Everything we have configured exists only in volatile RAM, sustained by a continuous electric current. If the switch loses power for even a second, the memory banks clear, and the device reverts to its defenseless default state. To create persistence, we issue the command copy running config startup config. This writes the active state out of volatile RAM and into the permanent NVRAM. Without the procedural discipline to save these changes, a single power fluctuation can instantly wipe out the security of your entire infrastructure. By methodically applying these commands, we have rebuilt the blank slate as a cryptographically locked, legally defined, and persistent network node. However, there is a final paradox. All logical software security is subservient to the physical integrity of the server room. An attacker with physical access can pull the power cord and initiate a hardware bootloader bypass, subverting every layer of cryptography we have deployed. To test your knowledge, look at these 3 core icons. Can you identify the command missing from a wide open console port? the difference between a password and a secret, and why a power cycle wipes an unsaved configuration. True enterprise protection relies on a combination of perfect software configuration, relentless procedural discipline, and unbreakable physical security.
Okay, we're back. Now that you had a chance to watch the video, let's actually do some work. Remember, we're using Packet Tracer, and by using Packet Tracer, it gives you a chance to practice. So here is what we're going to do. You were able to learn in the last Packet Tracer how to access a Cisco switch through a serial console port. You were able to display, configure basic device settings, and you did some optional work where you access a Cisco router using a mini USB console cable. Now, with that being said, we're going to go ahead and move to the next level, which is actually working with a switch. So I'm going to grab a switch here, and I'm going to grab a PC. Remember, Packet Tracer is great. Let's go ahead and grab our console cable and actually use that to connect. We're going to use RS-232 and go up here, and we're going to connect to the console. So that allows us to have a connection with the switch. Now, it's a couple of things that you learned in that last one. The first thing you did, you learned how to click on the PC, go to desktop, and click on terminal. And you see the configuration right here. So we're going to go ahead and click OK because that is good. And you can actually see right here the operating system and the image that's on here, 2960. Now we're going to go ahead to the prompt, as you can see right here. And we know that we can type in one of the first configuration commands that we needed to learn, and that was simply show version, which we just got to looking at the same thing already. Okay, so that was your first command, and you know that, and with that you was able to see what type of image you have on this switch. Now you can do the clock. That was another command that you had to learn how to check the clock. And as you can see, this is a old setup right here. This is the time the actual switch was created. Even though this is a packet tracer, this is the time would be on that particular switch. We can go from there and begin to set the clock up by simply going ahead into enable, and then we can start doing the clock settings. Remember, this was a command you learned in the last one, so you fully aware of this. And by using the question mark, you get to see how to set it up. Now I'm gonna go ahead and just put anything in here to set it up because you already know how to do this. But we're just gonna go ahead and drop anything. And I'm not gonna waste time by going through all the other stuff because you already know this. So I'm just gonna say May, I'm gonna say 13, and I'm gonna say 2026. Okay, and you know how to check by just saying show clock, and you see that the time was changed. Simple little stuff. So you understand all of this. We don't have to keep going through it. You already understand those commands. Now, the reason I went through those particular commands is for you to continue to make sure you remember those commands. Okay? Now, let me go ahead and go back in here and proceed to go to the next demonstration. Now, in this next demonstration, of course, we just gonna basically follow these particular objectives. we're going to go to verifying the default switch configuration. We're going to configure a basic switch configuration. We're going to also configure a banner for the actual switch. And then we're going to move it from just a basic running configuration and put it in NVRAM, just like you saw in the video. So always look at that video. Now let's go ahead and do this, because remember, students, you can handle this. Now just remember, this particular activity, we just still on basic configuration. We're not going anywhere other than just simply basic configurations. Okay, so let's do this. Let's take a look at the switch and do show running configuration. But I'm just gonna say, well, I'm gonna type it in first the correct way, and then as I proceed, I'll make changes to the shortcut way, you know? Okay, so running configuration. And this just shows me what's in here. You should always do this, because this lets you know if this switch has been configured. As you can see from here, running configuration, nothing has been configured on this switch as of yet. So you want to make sure you do that when you get a brand new switch. Like it says, out of the box, nothing should be configured on it. But you have to check it. That's your particular job. That's no one else's job. You, the network technician or the network administrator. So now we're going to go to config. And like I said, on the first time, I'm going to type it all the way in. Terminal, because we're going to move to a configuration level. Okay, configuration privileges. We're going to move there. Okay, so I got config terminal. Now, as you can see, it changed. So we went from privilege mode, privilege execution mode, to configuration mode. Okay, remember these particular terms. Now, I'm going to go ahead and put in a host name. You should always name the device. So that's the first thing you're going to get, is you're going to get to the point where you can name the device. And I'm going to hit exit, because you see now that this device has been named. If you take a look at it right here, we went host name and it changed to S1. So it's now S1 instead of switch. That's important, because in corporations, your switch, wherever it's located, must be named to that particular location. So it'll be easy for you to find it. Now, the next thing I'm gonna go ahead and do is just simply go back into config T. Now I'm gonna shorten it because you already know the long version that should be typed in. And then I'm gonna go to line console, and I'm gonna change line console so I can have security on it, okay? And I'm gonna hit enter. Now, I'm gonna go ahead and put a password on there, because I want to make sure that I protect it. I am the one who's configuring this device, so I don't want nobody to come behind me and start working on it. So I'm gonna put a password where only I can get in. So I put password, let me in. Then I said log in. This is when you log into it. And then I'm gonna say exit to lock it in. And I'm gonna exit to get out of here. Now, let me show you what I actually did. I'm gonna type exit again, and that's gonna take me out. But if I hit enter, it's asking for a password. So now when a person puts that console cable in, and let me show you what I'm talking about so you'll get a real good understanding. When a person comes here and actually try to put a console cable in here, they can't get in because I put a password on this console right here. So the password is locking this down. When you start working on these devices and configuring them, you have to put a password so someone wouldn't come behind you and make changes. So that was a good thing. We got a password on there. We don't have to worry about somebody coming to make changes. and you saw me type the password in, let me in, and that's why I'm in. It's saying it again, okay, let me type it in again, let me in, and I'm in there, enable. Okay, I'm back at privilege mode again. So you want to do that, okay? You want to make sure no one can sneak in behind you. But now I want to put a password on this here too. So I want to put a secure privilege mode password. So I'm going to go ahead and do config T. And from there, I'm going to go enable. Because I want to make sure no one can get in here. Even if they figure out the password, which they shouldn't, they cannot get in here to actually make the change. I'm gonna make this a harder password. In my mind, it's gonna be harder. It's really not. C1 $C0. Okay, now I'm gonna go ahead and click exit, and then I'm gonna hit enter and then exit out of here. Now watch what happened. I got a password there. Correct. So that is let me in. Okay, now I'm gonna hit enable, and I got a password right there because you cannot get in privilege mode. And that is just simply C1 $C0. And that lets me in. So now I can go to the next level. So you want to do that. You want to lock this box down so no one can get in here and proceed to cause problems. Now, what I want to do here is show running config. Well, I'm gonna do it the short version now. I'm gonna say show run. Okay, that lets me see the running configuration. And when I say running configuration, I'm talking about the configuration that's in there, the changes I made. As you can see right here, I put a password in there. I put the name of the device in there. So this allows me to show you the things that I made changes to. But I got a problem. Here is a password where you can actually see the password. Now, we do not want that to be like that. So we have to change that. And how we'll change that, we want to make sure we encrypt everything. So with that being said, let me back up for a minute. Remember, you have to make sure no one can see your passwords, even if they get in there. Config T. Then I'm going to say enable secret. I'm going to put secret, and I hope I spelled it right. It looks like it is. Enter at, I'm just putting the word in here, secret. Let me see if I spelled it right. It's a secret password, something like that. Okay, so we got that in there. Then I'm gonna go exit. Okay, so now I just locked that in right here. Right here, you just want to go config, and you want to say service password. I'm gonna spell this all the way out. Encrypt. And you want to do this because you want to make sure no one can see your passwords. Okay, now we're gonna click exit, and we're gonna go back and say show run again. Show run. Okay, let's spell that correctly. Okay, now let's look. See what we did? We encrypt these passwords. I encrypted this password to make sure that no one can see it. Now, let's be honest with each other. If you're a good hacker, this is nothing. You'll hack this in seconds. So don't count on that. We got other ways, and as we proceed in these lessons, you're gonna see other ways that we can hack. One of the first ways that we can make sure that our passwords are unhackable is to do this. Now, this is not a password protection. This is just simply letting the hacker know, hey, you're about to go to jail. So we want to go config T, and we want to come back into configuration mode, but we're going to put a banner in there, And the reason we putting this banner in is because we want that hacker to understand one thing: you're wrong for being in here. So they can't say, hey, I didn't know I didn't supposed to be in there. Yes, you did, because we put in a banner in here to let you know you cannot do this. You cannot hack us. And legally, this is how you're supposed to do it. It's basically to protect your organization from being hacked. And if they do hack you, you can actually lock them up. I mean, that's how it is, you know. But some people gonna do it anyway. So there you go. So now I'm gonna say show run, because I want you to see that now we have a banner in there. Show run. Like I said, these are basic passwords protection. We really don't use this, but this is just showing you how to do it. And as you can see, we got the banner in here to notify them that they breaking the law. So with that being said, all of that is good. That's basically all we have to do. The last thing we're going to do is we're going to do copy in privilege mode, running config, because we want to take it from running configuration to startup configuration. So if the router, the switch, or any of these devices shut down by some power surge or situation, these devices will be protected. So that's pretty much it, people. I'm gonna do another show run just to let you know all of this is in here and point out the things we covered. Remember, we covered several things. We made changes to the name. We changed the passwords, made them solid and secret. We made sure that we had no text passwords in here. And the last thing we did was we saved it to the running configuration, to the startup configuration. So if it shut down, we'll still have this configuration in here. With that being said, students, watch the entire video. And if you like what I'm doing, please like, subscribe.